So now let's go ahead and go into our Powerable actor base. Um, so there's a few different ways that we can handle this, but the default boilerplate is going to be pretty good. Um, so the only thing is that under the U class, I want to add, so this concept of U class, and then there's also U property and U function. This allows you to pass in specifiers that help the Unreal Engine know what to do with these classes or variables or functions. And in some cases, it'll also help to have these declarations. So just having that it says U class here, even if there's nothing in the parentheses, helps this class to be properly garbage collected when destroyed. But I'm going to add a couple of specifiers here. I'm going to say blueprintable, common, or so blueprintable, comma, and then blueprint type, comma, and then I'm going to make it abstract. And abstract just means that the Powerable actor base itself can't be made into an actor or the parent of a blueprint that is placeable in the scene. You need to actually make another child class of it. So this is just going to contain like the parent behavior. And so first of all, we need to actually implement the interface in the same way that in the editor, we added that in the settings for a blueprint. In code, it's much easier. You just go to where it says, this is the name of the class, and then colon, and then this is what the class inherits from. So remember, we selected actor, so that means it says it's public A actor. And A is just a prefix that is used for actors, so that is automatically added to the name of the actual class and the name of the actor. We're going to hit comma right after that, and then we're going to do public I Powerable interface. And then right below, see, we have this. This is the constructor for this class because it's an actor. It has a constructor. This is what's going to actually initialize variables the moment that it gets created and set. And so just below that, we're actually going to want to set up our overrides. So I'm just going to like click on the end of that line, hit enter a couple of times, and then I'm going to do a virtual bool get has power. And then you can just like press the arrows up and down to scroll through these. And then I'm just going to select enter. And then this is going to automatically make this function into a virtual bool get has power override. And this is actually overriding the function that is in our get has power interface function. And then we're going to do the same thing a second time for the try power, or try to power, virtual bool try to power. And then below that, you'll see that the boilerplate already added in begin play, which is the one we use for blueprints as well. But it also added in virtual void tick under public. And we actually don't want that. So we're going to, let me actually just delete the tick, but I'm not going to delete the public. So just so you know about these access modifiers, everything between this and the next access modifier is going to be using this modifier. So public means that it's going to be accessible from other C++ classes. Protected means that it's only accessible from this class and children of this class or classes that inherit from it. And then if you had private colon, then that would be literally only accessible for this class and not even for its children classes. Now, generally, I tend to use protected or public just because I don't know exactly what it is that I'm going to decide I do or do not want to have accessible to the children. And then I will mark them as private if I realize I need to do that. But for now, I don't need to have this private access modifier. I'm gonna move this down out of the way so we have a little more visual room. And so we need two functions that are going to need to be virtual, but because we're creating them in this class, they won't be a void. I'm sorry, they won't be an override. So what we're going to have is a virtual void power on with parentheses, semicolon, and then actually I'm just going to copy that line, drop down, and I'm going to just change where it says power on to power off. Now we need to make the variables that we need in this class, and you can again do what we did at the beginning, where you look at your pre-existing blueprints and you right click and select preview C++ header, and then you can copy a bunch of the values there to get a jump start on this. But I think that because that's going to be potentially a little bit confusing or distracting, let's just type it in. So we're actually going to need one public uProperty and one protected uProperty. So I'm going to grab the protected there. I'm going to grab that down there. And what we're going to do is I'm going to type in the word uProperty. And this is the uProperty macro. And then I want this to be blueprint read only. So usually blueprint read write would be if it's something that you want a getter and a setter on, but read only means you can only use a getter in blueprint. And this is different from the public and protected access modifiers, which are going to affect the C++. Blueprints don't actually look at your C++ code for that. They look at this uProperty specifier. Then I'm going to make a comma here, and then I'm going to select visible anywhere. And then what I need here is I need a uScene component. And so then if you just type in the words uScene component, then you do like a shift asterisk. That means that we're going to get an instance of a uScene component, and then we're just going to call that default scene root. But Unreal actually has a way that they want you to do this that's sort of the correct Unreal way. While this is valid and this will work, if you look at what it comes from the preview header, it actually doesn't use this version of an instance of a class. It actually, we remove the asterisk there, and instead we use T object PTR for T object pointer. And then that creates these little less than, greater than, and we want to just put the uScene object in there. And this is going to be what we're generally going to want to do for these uProperty declarations. Now, if you're still passing that kind of value into a function, you're going to need to use the uScene object component asterisk for the reference of the instance of the class. But this is what they want you to do when you set this up, because it gives the garbage collection system and the API framework a little bit better control over those variables. So, okay, then we just need one other variable in the protected section. And because I want to make sure that this is properly garbage collected, I'm going to make it a uProperty. But I'm not going to put any specifiers in the uProperty. I just want it to be a uProperty. And I'm going to make this a bool has power. And we can make that equal to false by default if we want to. And then there we go. Okay, so now we have that. This is the finished header for our Powerable base, but we still need to implement each of the functions. So I'm going to say select all the ones that have, I can actually see here because it has the is not implemented kind of caret or whatever you want to call it. So I'm going to Alt-Enter generate definition, Alt-Enter generate definition. Alt-Enter, generate definition for power on. Alt-Enter, generate definition for power off. And then you'll notice here also that there's this red squiggle underneath tick. That's because we actually removed tick from the header, so we want to remove that as well because that was added by default. And so then it looks like we have all of the declarations and definitions that we need. So now let's jump in here. First, this is what's going to be happening whenever the class is first initialized. This is the constructor. And so there's only one thing in here by default. Primary actor tick.b can never tick. That means it's going to run the tick function or has the ability to run the tick function. We actually don't want to do that because we don't have any tick behavior we're going to be using here. So we want to set that to false. But then now what we want to do is we want to initialize the default scene root. And so we created that scene root, and that's just basically what we need to be able to parent child objects in the hierarchy of this class. So what we're going to do is inside this constructor, I'm going to just make a really quick comment. Initialize, so that's the double slash initialize the default scene root. And then I'm going to say default scene root, grab that variable, equals, and then this is just a convention that you're probably not going to know right off the bat, but you just can do create default subobject and then hit enter. And we're going to say use scene component in the less than greater than. And then inside the parentheses, we want to give it a name with a text macro. So type all capital letters text and then parentheses. And then we're going to type in quotations. And we're just going to call that default scene root. And then at the end of that line, we just want to hit the semicolon. And then we need to actually make this into the scene root. So that's with a function called set root component. So you're going to be calling this on the Powerable actor base. And we're just going to plug in that default scene root and then semicolon. And there you go. Now that's going to be enough to initialize this. Then we want to go to our next one, has power. You see this returns the iPowerable interface get has power, which means it's going to return false because that's what we set up in our initialization. What we want to do here is we want to return the has power variable. Now we've got to implement the try to power specifics. And so first of all, because it's trying to power, we want to have a condition where we actually don't do it. So we're going to say that it will be if has power equals power goal. And that means like, so if it currently has power and that's true, and then the goal that we're trying to get is to power goal true, then that means that we actually don't need to do this if it already is in the state that we want it to be in. So then we're just going to return false if that's the case. And then after that, we're just going to say if the power goal is true, we want to power on, and then else power off because it means this power goal is false. So if parentheses power goal, then we're going to create curly braces, enter, power on, so we're going to select the power on function that we created, semicolon. Then we can click to below these curly braces, hit enter, else, hit enter. That should automatically create our curly braces. And then we can go to power off. So I just started typing PO and then hit the down arrow a couple times to select power off and semicolon. But then because this is a bool function, we actually need it to return a value even when it was successful. So that means that just after this, we're just going to add a return true semicolon. Okay, so now that we've got that in place, let's go down to our begin play. And this already implemented super begin play. So super like this just means that you're going to call the parent. And it's usually a good practice to just do that. So after it calls the parent, this means that in the future, if we make something else that inherits from this and we call super begin play, then that it's going to do what we wrote here. And then when we're doing this here, that means that it guarantees that anything that actor already has included in it for super begin play, that will also fire off as well. So now we just want to make sure that if the Powerable was set to has power before it begins play, we want to say if has power, and it actually is going to be pretty similar to this. So actually, rather than doing that, let's just delete this here. Let's go up here and grab this whole power goal, if power goal, power on, else power off. We're going to copy all of that, and we're just put it down here. But instead of using power goal, we'll use has power. And this just will make sure that on begin play, we also execute this initialization, but we don't want to use try to power, because in the future, we're going to have other things that might happen in try to power, like triggering a sound effect or something like that. And we want to try to separate that out. So this time we're just explicitly calling power on and power off. That way we can make sure that it does so kind of silently. And we don't need to perform all of the exact logic that would be performed when a player themselves is trying to power. And then also we know that if we call power on and power off directly in this code, we know that it's definitely going to do it. It's not going to ever like return false. And so just because this is kind of initializing or setting up the Powerable, we want to just make sure that we're doing that. Now our power on and power off are really simple because this is the base class. We just need to set has power equals true. And then in the power off, we want to set has power equals false. But in our blueprint version of this, we actually did like a print string or a log string. And so I just want to make sure that I actually give you a way, just so you can see really quickly how you would do that. So I'm going to make a UE log macro. So that's UE underscore log. And then there's parentheses. And then this asks for a log group or category name, then a verbosity, and then it wants you to pass in formatted text. So for the log category name, you can create your own category names, but I'm going to just use log temp, which is fine in most cases. Then for the verbosity, I'm going to use log. That means it'll show up in white text in your log, but you could also do warning, which would show up in yellow text, and error, which would show up in red text. But log is fine. And then comma, and then I'm going to use a text macro, capital TEXT, parentheses, and then quotation marks. I'm going to say power on triggered for, and then I want to use the name of the object that we just used. So in this case, it's going to be the Powerable actor base itself. So we actually can pass variables into this formatted text. And the one for string is percentage, the percentage symbol, S. And then what we do basically, any of these types of variables like this will then have to be defined in order after the text macro. So I will go outside of the parentheses for this text, type comma, and then what I want to do is I'm going to have dereference the name variable for this Powerable actor base. So I'm going to type asterisk this, and then arrow, so hyphen greater than symbol, get name. And then that means that that will include that in the name. And also I want to make a space here. I don't need a capital T. So then that log will actually work just fine. So I'm just going to make sure that I make semicolon to end that line. And then I'm going to copy this and I'm going to paste it directly into the power off. And I'm just going to change where it says power on to power off. And then this way we have a basic idea of how you can set up UE logs. And also this is much easier to do here than it is to do in blueprints. And there we go. We're done with the Powerable base. So let's real quickly just hit Control B on our keyboard and see if it builds properly. Okay. And it said build succeeded. It says with warnings, but that warning is actually like this weird Microsoft build warning. We don't need to really worry about that. But it build succeeded. And so we know that that's good.